Good morning, everybody. I hope that you are having a fantastic weekend on this rather snowy period in North Texas history. My hope for today's lecture is that we finish up chapter 2. The reason is, as you know, we've been on chapter 1 and chapter 2 the last few weeks because we had to build a very firm foundation on methodology and on statistical analyses, which we'll get to today. But at this point here, I want to kind of get out of this part and get into the bio part of biopsychology. And so after we finish this lecture here, next week is when we start to get into the more specific parts of understanding biology from a psychological perspective. My hope for today is that we get through a basic understanding of statistics and statistical analyses, and then we finish up with a brief discussion on ethics. And so in my mind, after going through a few dry runs in my head, I feel like this is going to take us probably about an hour worth of time. So set aside some time, watch everything. I'll upload the slides later so that you have that reference point. But this should hopefully get us to where we need to actually be to understand what it is that we're looking at in terms of biological understandings and psychological concepts. I hope that you were doing well. There are a few assignments up on the website now, so I hope you get those done as well. And then I'm looking forward to our next sort of unit. Now, as you remember, there is no exam in this class this semester. We might have a few upcoming quizzes coming up, but then I hope that we're going to turn to later a few projects and a few documentaries and things that we can actually do to make the experience very enlightening for you as we finish the rest of the month and finish out the rest of the semester very strongly reflecting on our understanding of the juxtaposition of biology and psychology. So let's go ahead and get started in this final piece here. So today we're going to talk a little bit about experiments and why and when we do experiments. Now, as you recall, last week we spoke about correlation, the correlational design. Now remember, correlation does not what? Does not equal causation, right? Correlation simply means we found an association, either a positive or negative association, right? Remember, positive association means as one variable goes up, the other variable goes up. And remember, a negative or inverse relationship means as one variable goes up, the other variable goes down, right? So remember, correlational design is designed to point us in the direction. It's designed to give us an idea. Correlational design says that there's some way that these two variables relate together, and there's some magnitude of the directionality in which they are related to one another. But they cannot predict causality. We can't say that one variable caused the change in the other variable. We can't say that the other variable was a result of changes in the first variable, right? Additionally, correlational design lends itself to the third variable issue, right? There could be some third variable, some third mechanism that's taking place either between the two or that's focusing on both of the two that's causing the changes that we see in those two variables. So correlational design is a good first step. It's a good door to go through, tell us where we need to go next in order to understand what we're actually testing. Today, hopefully, we're going to talk about experiments. Experiments are when we can say and talk about the causality of a thing. Experiments say we can note without uncertainty that a change that we implemented in an independent variable resulted directly and impact directly what we saw take place in the dependent variable. So hopefully we'll be able to sort of contrast the difference between independent variables and dependent variables. We'll be able to talk about what experimental groups are as well as control groups, and then maybe explain the differences between single blind and double blind and why both are necessary in order to implement good science, okay? We want to be sure that we implement good science. Okay, so when psychologists set up experiments, they think if I do action A, then the people in my study will do action B. Or in this case here, if I do X, the people in my study will do Y. X is the independent variable. It's the variable that you manipulate in your study. The independent variable is the variable you manipulate in your study. The dependent variable is the variable that sort of reacts as a result of the manipulation you did in your independent variable. So your dependent variable depends on what changes you implemented in your independent variable. Okay, so know the difference. You run an experiment, the thing you are changing, the thing you are setting up is your independent variable. The thing that changes as a result of how you set that up, that's your dependent variable. So your dependent variable doesn't change at all. You don't implement some change in your independent variable. So for example, let's say we want to do a study looking at cell phone use and driving, right? Now, do cell phone use and driving mix? Well, not only is that poor grammar, right? But also I would probably have a more specific type of scientific question. We can get into that later. For now though, for the purpose of this, we'll just say, does cell phone use and driving together, what is likely to happen, right? So let's say we have a hypothesis. Now remember, we spoke about hypothesis about 2 weeks ago, right? What's a hypothesis, right? It's this educated guess based on what our theoretical framework says ought to happen. So based on the theory, I think blank will happen, right? Based on the theory that driving requires all of your cognitive abilities, I have a hypothesis that your cell phone use will impair your driving ability. So we have groups, we have 2 groups, right? We have them in a driving simulator, and in this driving simulator, we give them a cell phone, and we say, now that you have the cell phone, you have to text on it, call on it, check social media while you're driving in the simulator. And in the simulator, you have to avoid hitting pedestrians, hitting other cars, running off the road, veering off the road, running red lights. So you have to maintain perfect driving while you are utilizing your cell phone. So in our experimental group, right, the experimental group is the group that gets your manipulation. Now remember, your independent variable is the thing you change. Your dependent variable is basically the variable that changes as a result of the changes you implement. So you have an experimental group. Your experimental group is the group that gets in the simulator, and while they're driving, they're using their cell phones, they're texting, they're checking social media, and they're doing all these things. And you're going to measure the number of collisions that they have while they're doing that. Your control group is the group that doesn't get a manipulation. Why? Because you need to compare what happens for people who get your change against people who do not get your change. So they're the control group, i.e. they're the normal group where you did not implement a change. You can only understand and measure the effect that your experimental manipulation has if you compare it to a group that never got the manipulation. So you must have a control group when you do an experiment. You must have a group that never got the change in order to understand what happens to people in the study who get the change. So in this group here, your experimental group are the ones who must do the simulator and talk on the cell phone. Your control group does the simulator, but they're focused fully on driving. They don't get the cell phone. And what we're going to measure, okay, is the number of collisions individuals have. So let's start it from the top again, because I want to make sure you don't get this confused, because you need to be able to understand this for the rest of the semester. Your independent variable gets to change. Your dependent variable is the result of what happens in the changes in your independent variable. Your experimental group is the group who you implement the independent variable change with. Your control group does not get the independent variable change. So in this example here, You've got your independent variable, use of cell phone while driving a car, and you've got your dependent variable, number of collisions as a result of using your cell phone while driving a car. Your experimental group uses the cell phone because the cell phone use is the independent variable. So your experimental group has to drive in the simulator while using their cell phone. Your control group doesn't use a cell phone at all. You're comparing your experimental group right here to your control group right here. So let's say that this group here has a large number of collisions, your experimental group, and that the control group has a very low number of collisions. Okay. Now, as you get more and more into statistics and more into psychology, you'll learn that this gets much more complicated on a bigger level. But for now, all you need to focus on is this simple demonstration. What you want to do is you're going to want to compare the difference between the two groups statistically. Let's say that your experimental cell phone group has a large number of average collisions, but relative to your control group, who has a very small number. Is the difference between the two groups large enough to suggest statistically that cell phone use inhibits driving ability? If it is, you can show causality. If the difference between these two groups is large enough statistically, you can show that cell phone use inhibits driving ability. And that's based statistically. And you can show that there's such a statistical difference that your manipulation could not have happened by chance. In other words, the effect you find is an actual real effect. You actually have found and discovered a scientific thing. So look at this for a second and see if that makes sense to you. So there are things called experimental effects. Now, last week we spoke a little bit about naturalistic observation and laboratory observation. You remember what we said? Just by coming into the room, I'm changing and affecting how you act. And if I bring you into my laboratory, your behavior will also change because it's not a natural setting. If you're walking around a place and there's people with lab coats on, clipboards, they're taking notes, they're taking measurements, your behavior is going to change and it's going to react differently than if you were at home by yourself on the couch watching Netflix, or in my case, HBO Max, right? So experimental effects are the change in behavior as a result of what the experimenter does. So you have to understand that even though we're running an experiment, it's not exact. And the reason it's not exact is that participants' behaviors change as a result of what the experimenter is doing, as a direct result of that. Because in a natural state where you were by yourself, your behavior is going to be different than if you know you're being observed. Even if you minimize the observation, even if there's no experimenter in the room, but I know that somewhere in the room there are cameras and microphones in this laboratory, it will still change how I react and make it less than natural. So experimental behavior can affect how the independent variable is sort of manipulated, which then in fact affects the dependent variable, right? But also the dependent variable is going to change as a result of what the participant is actually doing. And so this diagram here should have had another arrow, and the arrow should have also been pointing from the experimenter to the participant. I change your behavior by being in the room with you. Right? So, an example of independent variables, right? What types of dogs might elicit different levels of fear? So if you see a little terrier, right? You might be slightly agitated or annoyed, especially if it's 3 o'clock in the morning and they're barking like crazy. But if you see a Rottweiler or a pit bull who is on the loose, right, and running towards you, your level of fear might jump a couple of levels, right? Your heart rate starts firing and you just take off running. I imagine if a dachshund runs towards you, it will elicit a different level of fear than if a German Shepherd runs towards you and is slobbering and is barking aggressively, right? So we can see type of dog, independent variable, affects dependent variable, level of the fear that you have. Right? So again, you see this one run towards you, you might stop and be like, whose dog is this? That's kind of cute. This bad boy runs towards you, you might take off running and drop everything that you're holding, right? So type of dog influencing type of fear. So we assign people to random groups, right? So here you see the groups. Now this is important. Everybody's part of the same population, right? So this is an important graphic. Split them up. Your experimental and your control group. Your experimental group, let's say this group here on the left, gets your manipulation. So they're exposed to different types of dogs, right? This control group is not exposed to different types of dogs. So maybe they're exposed to only one type of dog, or maybe they're not exposed to any dogs at all, right? Another one, does Viagra work for women? That is actually a question that has been on the minds of scientists for years. For some reason, we just want to give everybody blue pills. We just want to make sure everybody is having the best sex they can have by giving them blue pills. We know what the effects are with men, but what are the effects with women, right? So we actually give, so here is the experimental group, right? So in the experimental group, we give them actual Viagra, right? And we measure the percent reporting an improvement in their sexual lives and in their sexual responses. And here in our control group, we give what's called a placebo. What's a placebo? A placebo, and I know we're going through a lot of definitions now, but that's part of the reason that this is on video, that you can go back through and read in the book so you can follow along, right? A placebo is essentially a fake pill. So here in the experimental group, I give you Viagra. Here in the placebo group, I give you a blue pill that's diamond shaped that looks like Viagra, but it's actually a sugar pill. It's got no therapeutic effects whatsoever. So it looks like you got the manipulation, but you didn't. Now, there is something, and I don't remember if this is in the slides or not, but there's this really cool effect that we've seen in psychological and medical science. It's called the placebo effect. The placebo effect says, I give you this fake pill that resembles the real pill, but your body responds as if it's the real pill. So let's say you are being treated for depression in an experiment, right? No, actually, let's do a different one. Let's say we're treating you for anxiety, okay? So I give you pills to measure how your anxiety levels fall. But if you're in the control group, I give you sugar pills that resemble anxiety medication. You get that, but you report that your anxiety levels fell. So your body is responding as if you got the real pill. This is fascinating from a scientific standpoint, and it's something to be excited about, because what it means is that our minds are really powerful. Our bodies and our minds are really powerful. You can fool your mind into thinking you are getting better, and you can fool your mind into responding in such a way as to actually get better based on just the thought or concept that you have a pill. If a man is struggling with erectile dysfunction, right? You can give him a fake Viagra pill, and suddenly He's reporting that he's experiencing stronger erections, that he's lasting longer when he's in sexual contact, and his overall satisfaction with sex is stronger, even though the pill has no therapeutic effect. We see this all the time in medical situations. So this placebo effect is very strong. It's been captured multiple times. And even here, even in this example here, we're seeing that women who receive the placebo pill, i.e. the fake sugar pill that resembles Viagra, that they report having a higher quality and higher improvement in their sexual responsivity. So the placebo effect is real, and the placebo effect can act as the real pill. All right, so continuing our conversation on experimenter effects. In a single blind study, the experimenter knows who is in what group, but the participants do not. You come into my lab, I know that you received the real Viagra pill, and I know if someone else received the fake placebo Viagra pill. But you, as a participant in my lab, don't know what pill you received. In double blind, I don't know who received what pill. It's totally at random. There is a way to log who received what pill so I can find out later after the study is done. But I have no way to know when you come into my lab what pill you received. It's at random. Why might you implement a double blind study? Think about what we discussed last week before I tell you the answer. Why might you implement a double blind study? You would implement a double blind study because it's the best attempt to reduce confirmation bias. If I know you received the Viagra pill, I want so badly for there to be an effect that I'm likely to unconsciously bias my study to show that women who receive the Viagra pill are actually having an effect. They're actually experiencing greater sexual satisfaction. But if it's double blind and I don't know, then it removes the bias that I have as an experimenter trying to conduct my study. It removes the bias. It takes it right out. So a double blind study is a safe and effective way to try to get as objective a study as possible. So we've spent some time now discussing experiments, right? Discussing advantages and disadvantages. So advantages, it allows the researcher to control the situation, right? If I'm doing an experiment, I can control exactly who comes in, exactly who goes out. It permits me to identify cause and effect and distinguish placebo effects from treatment effects, right? So there's Viagra here. This is our treatment effect. This is our placebo effect. And experiments can tease those both out. Now, additionally, the situation is artificial and the results might not generalize to the real world. And sometimes it's very difficult to avoid experimenter effects, right? It's very difficult to avoid experimenter effects, right? So, and sometimes, and to get into more of a discussion about experimenter effects, like oftentimes experimenter effects are unconscious, right? I want you to react a certain way. So I'm doing certain things, I'm saying certain things, I'm moving in certain ways that might force you to react certain ways, right? So those things happen. How I respond to you, the distance that I am to you, how I address you, the sense of familiarity we have, how I present things to you in the experiment. All these things have an effect on how you're going to understand what's going on and how you yourself will react in the experiment. Okay, now, So let's pause for a second and we're going to switch gears. One of the things that I think we have to talk about is sort of cross-cultural research. So as we get into our discussion on cross-cultural research, there's three main things that we need to think about, which will affect the research going forward. Now, this is something we'll get into even further if you take my multicultural psychology class, which, by the way, plug, you should definitely take that at some point. I will definitely be teaching it. You should definitely take that class. But going back to this discussion here, right? The first thing is methods and sampling, right? So psychology as a whole is really based on a lot of Western principles, and in particularly a lot of Western Americanized principles. And we can drill down even further and say that a lot of the things we understand about psychology today are based on a white male understanding of theoretical concepts, right? So you take these theoretical concepts and then you apply them to a different culture altogether, right? Let's say, for the sake of this discussion, China. Well, China has different values, different ideals, different customs than we do. So you take these Americanized concepts, you ask native Chinese-born individuals in your study, and then you try to make an assessment of these Chinese participants based on your Westernized understanding of theoretical concepts. That's an error. That creates bias. It creates bias because you're judging participants' response based on your limited cultural understanding, right? So additionally too, there's sampling issues, right? So sometimes it's hard to get individuals from a different culture or different country in your study. And sometimes it's hard to translate the materials such as surveys, questionnaires, right? Other experimental procedures into a language that translates the exact meaning you need for it to have in order for them to perform adequately in your experiment. Secondly, an issue is stereotyping, right? If you look, here's the truth, and it's an ugly truth, but it's the truth. All of us have bias. All of us stereotype, even Dr. Sims, even you, even your parents, even your children, even your other professors in the psych department, at UNT, in this great state of Texas. All of us have our own biases, beliefs. All of us have our own stereotypes. If you bring certain stereotypes into your research lab, and then you bring someone into your lab who you think fits that stereotype, and they have a different cultural experience than you, what does that create? It creates experimental bias. You see this a lot in cross-cultural studies because unfortunately, individuals don't take the time enough to study the culture before they do an experiment with the culture. And then lastly, it's this idea of reification, right? Which essentially says you see the bigger part before you see the whole before you see the smaller parts. So in other words, let's say you're buying a car, right? You're likely to see that it's a BMW, but you might not pay attention to the fact that the tires are scratched, right? There's a crack in the windshield. The seatbelt is cut in the back seat. The trunk doesn't lock all the way. The accelerator sticks. The brakes are owed. So you see this big picture, but you don't see the smaller one, right? So you say you want to study some concept in Africa, and you don't realize that there are over 50 different countries in Africa, and not all Africans are the same, right? Or you want to study some concept that looks at the concept of Blackness, but you haven't quite realized that there are different types of Black individuals, right? Or you're like, I want to study some concept within Brazil, and you don't quite realize that there are different communities within Brazilian culture. and that they might not all have the same traditions, values, and customs. So you see the big piece, but you don't drill down enough to see the smaller piece of what you should be studying. If this in any way has excited you or piqued your interest, take my multicultural class. All right, evaluation. This is a pretty important part of the chapter 2. So pay special attention here and be sure you go back to the book to read as well, okay? So, all right, so hopefully what we would do is talk a little bit about statistics. Look, statistics are going to be your bread and butter over the next few years. More so if you decide to get a master's degree, more so if you decide to get a PhD, even more so once you're actually in the career. Dr. Sims is telling you this now. You decide to pursue this degree, you decide to pursue master's level, PhD level training, you will have to get good, and you will have to get very good at the use and implementation of statistics. It's just inherent to the field. So many of the concepts we have, so much of how we understand psychological theory is based on our implementation of very advanced and specific statistical analysis. So when you have a result after your study, you have to do 3 things with them, right? You have to describe what the results are. You have to assess how reliable those results actually are, as well as what the meaningfulness of those results are. And then finally, you have to explain them. You have to be able, now, and I'm going to do a little subsection here that's not really in the book, right? But you have to explain your results to the scientific community because we're in a peer review process, which means your peers look over your work and critique it. But you also need to be able to explain your concept to a lay audience. If you find some theoretical understanding that relates, for instance, the use of Viagra with increased levels of anxiety, you will write a scientific journal article to talk about those findings, as well as next steps for those findings. But also, you need to be able to explain what you did to the average person on the street. If you cannot explain your in-depth, specific, complex hypothesis and findings to the average person on the street, you have not done a good job sharing knowledge. Yes, you have to publish. Yes, you have to do articles. Yes, you have to share with other individuals who are in your field. But you ought to be able to go on stage and within a few minutes be able to explain to everyone what it is that you researched and what your findings were. That is good psychological science. That is good open science. And remember, we spoke about open science a little bit last week, right? So it's got to be able to be known by other people, but also everyone should have access to it. Everyone, not just other psychologists. So there are statistical procedures that summarize and sort of organize, right? So what you'll use a lot is the mean. And the mean is simply the average of all the scores. You additionally use the standard deviation. Standard deviation tells us how clustered or how spread together the scores actually are around the mean, right? So here in example A, you see that the mean is 5. Most of the scores are around the mean. Here, your mean might be 5, but you have a different range and a different variance of scores that are around it. So there's more of a spread. There's less of a spread here, but there's more of a spread in B. Right? So Inferential statistics, then, are those procedures that permit researchers to draw inferences about how meaningfully your statistical findings actually are. So it's not enough to do statistics. You have to do statistics and then explain why your statistics are significant. Why do they matter? Why do we care what your numerical findings were? What does it mean to us? Right? So inferential statistics tell us that. You will do significance tests. So you will not just do this simple calculation of mean and standard deviations. You will also do significance tests. Now, significance tests are important because they tell us how likely it is that the findings that you found were done purely due to chance. In other words, when you think about significance testing, I want you to focus on the real world. The real world is not easily controlled. The real world is actually very chaotic. We need to account for that chaos in our statistics. So your significance test will tell you what is the likelihood that what I found within the confines of this study was actually found due purely to chance and not due to any real manipulation that I did. We need to know that. Typically, we want to keep that percentage around 5%. We want to keep that percentage to, there's a 5% chance that what we found took place just due to chaos. But there's a 95% that what we found is a real concept that our study has unearthed. Every blue moon, you'll find someone who has that at 10%, where there's a 10% chance of what we found was due to chance. Every blue moon, but 5% tends to be the gold standard, and the platinum standard would be 1%. There's many. If you find something where it's only a 1% chance that it took place due to randomness, that is a very strong study. And typically the ones that get published are between 5% and 1%. Actually, that's incorrect. Excuse me. The ones that get published are between 5% and 0%, right? Because how great would it be to have a study where there's less than a 1% chance that randomness took place and caused the findings that you found? So between 0 to 5% is where we want that to be. Okay. So confidence intervals are things that we see across studies, right? So sometimes studies have multiple legs or multiple variations, right? So sometimes you read an article, it'll be like, in study 1, we found this. In study 2, in study 3, all the way down to study number 30, which means they kept replicating within the study the experiments. And study 1 might have 300 people. They go ahead and do study 2, which might have another 300 people. They do study 3 again. So it's continual studies that are part of one big large study, right? So this whole thing is one big study, but it's got multiple legs to it, as you can see. Your confidence interval is a measurement of the range of scores that we're fairly sure that the true value lies. So remember, this little dot here represents the mean, but this scale right here says that mean is just the average of everybody. Whatever the true actual score is that we're measuring on the study is going to be somewhere in this, and this is also 95%. So we have a 95% confidence that whatever the actual real score is of everybody, it's going to be somewhere in there in this range given the mean. So let's walk through that one more time. So in study 1, our mean is, let's say, 50. Right? I can get my mouse to show. Now, but the range here might be between 30 and 60. So in study 1, the mean is 50, but if you were to actually take the individual measurements of everybody in study 1, their scores 95% of the time would fall between 30 and 60. In study 2, the mean is 55. But the range here is, let's say, between 35 and 75. So we're 95% sure that the actual real score of people in study 2 is between 35 and 75, and so forth, right? Now, let's look at this right here, right? Let's say this is study 25. This one's different, right? The mean is not on the line. It's not even near the line. So once you start doing statistics, I'm getting excited here just because this is kind of fun. So something happened in this study. Something happened with the people who were in it, something happened with the experimenter, but something took place. If you can see where my mouse is circling, something took place because this is so far off everything else. So this is an outlier. It goes outside the expected realm of where scores on average typically have been, right? Even the study before it, right? The study before it was right here. Look at this space. Look at this. Look at this. Look at this. That's astonishing. Look how far off that is. Something took place in that study. We need to drill down and look at the data and figure out what happened. It could be anything. Technology could have went wrong. The people could have been of a different type of sample, but something took place to where in this study here, the scores are way off. Again, it happens later on in this follow-up study. Look at that. That's amazing. Look at that. These scores are lower. So this outlier is way higher than typical. And this one's way lower than typical. And we're 95% sure that for this particular study, participant scores are on the lower end. They're between like 30, they're between like 20 and like 40. When on average, they've been here around the 50 mark range. When you are taking data, and put this in your notes somewhere for when you get in your stats classes and when you go to take your master's degree, right? If something like that happens, you need to look at what took place. What was different? Why are these numbers so different? Why are they so off from what they should be, right? So you need to take some time to figure out what went wrong there. The confidence interval is good, especially over repeated studies, because you have a good idea of where the people in your study and where their scores actually were there. And that's adds more information than just having the average mean. The average mean is just the average person, but your confidence interval tells you within these averages, 95% of people fall within this particular range. That tells you something about your manipulation, and it tells you something about what people are doing in your study. So you always want to look at the confidence intervals. All right, so we've spoken about descriptive and statistics, which describe a concept. We've also spoken a little bit about inferential statistics, which help you to make predictions based on the numbers you found, right? So summarizing the data, descriptive. Likelihood that a result occurred by chance, inferential. Remember, we're inferring that there's a 5% chance that randomness took place in our study, right? Inferential provides a measure of statistical significance, tells us how statistically significant the findings are, if they're real, true findings or not. Tell you whether to call your mother about your results, right? So if it's exciting, you're like, oh my, I really found this amazing thing here, and you might want to call somebody to tell them about that. Inferential statistics will do that. When you're in your program, or later on when you're doing research, you will call your advisor and be like, I found something amazing. And your advisor's gonna be like, ooh, tell me about it. And you're gonna tell them all these inferential statistics, and both of you are gonna celebrate and be like, wow, psychology student, you have found something incredible. You have saved the field, which is what all you're gonna do eventually, right? So inferential statistics are a bit more powerful than descriptive, right? Examine a confidence interval around the sample mean. Inferential statistics then can infer that with these findings, 95% of people in our study, their scores are going to be in this range. The other 5%, those scores are outliers. And then compute how clustered or spread out around the scores, around the mean, the scores actually are. That's more descriptive statistics, okay? Know the difference between those two. I'm not going to test you on it, but you need to know the difference between those two because that will help you once you start to go through studies. So there are different ways to test different hypotheses based on different questions you're asking, based still on different psychological concepts that you're testing, right? So for example, let's say that you are like me and you are a developmental psychologist. I'm a developmentalist by trade, which I told you, right? So we can look at cross-sectional research. We can look at longitudinal research, right? Those two are different, and we would assess those statistically in different ways, right? Statistical techniques help us to determine if results are really important. So let's go through these together. Right. So a cross-sectional study is when you study different ages compared at a given time. Let's say that I study depression after the 2016 election, okay? And I can also study measurements of happiness and joy after the 2016 election. So cross-sectional means that I look at a group of 20-year-olds, 30-year-olds, 40-year-olds, and 50-year-olds, and I measure their reactions all at the same time. It could be I find that the 20 and 30-year-olds are happier, or excuse me, have lower levels of life satisfaction. So they were more depressed after the 2016 election. But I find that my 40, 50, and 60-year-olds have higher levels of happiness after the 2016 election, right? So I measured different age groups at the exact same time. Now, a longitudinal study is when people are followed and periodically reassessed over a long period of time. I bring you into my study in the year 2021, and it's a 20-year study. Every 5 years, I call you up on the phone, ask you questions, and I assess what's changed in the last 5 years. Remember, this is a very key developmental framework for studying things. We're looking at change through time, and time itself is a factor and a variable in the study. So I look to see how you've changed in 2021, right, to 2026, and then again in 2031, right? So I continue to look and to see what changes you've had, how you've changed. Then I come to find out that, and then at the end of the study, I measure what differences did I see on this specific measure from 2041 back to 2021. So it's a long-term study. Effect size. We don't really get into effect size as much as we should at the undergraduate level, but I hope to change that in some way. Effect size is a very powerful measurement. Effect size describes the strength that the independent variable had on its influence on the dependent variable. So effect size says it's not just enough to know that my manipulation changed something. I need to know how strong of a change it was, right? Back to our cell phone example. So we find that cell phone use does relate to increased frequency of car collisions. But how strong is that, right? Does it cause a lot of car collisions for everybody who uses cell phones? Or are some of the people getting in car collisions? Or is it a minor effect that only a few people are actually experiencing car crashes as a result of using cell phones? And then a meta-analysis think of a meta-analysis as an analysis of analyses, right? Think of a meta-analysis as combining data from several related studies, analyzing that data, and then getting an overall strength of the independent variable. There might be 45 different studies that have looked at cell phone use and car collisions. We take the data from each of those 45 studies, we analyze it, and we combine it into one big study that tells us the overall effect of cell phone use on car crashes. Meta-analyses are extremely powerful, and only a few people know how to actually do them correctly. But when they're done correctly, they're an absolutely beautiful statistical thing, and are guaranteed to be published in a good way. They're guaranteed to be published and to bring about interesting discussions. All right. So again, we've looked at cross-sectional. So I won't stay on this slide too long, but you can always stop it, right? This should tell you and demonstrates for you what this is, right? Group A, Group B, Group C all compare at the same time versus longitudinal. Group A is compared at different times. Different groups compared at one time versus the same group compared at different times. All right. We can't talk about science unless we talk about ethics. The field has to be made ethical. We have to ethically talk to our participants in order to get them to give us what we need, which is their data. Unethical practices cause harm. Unethical practices destroy people's lives. Unethical practices destroy the field. We have had many unethical studies done in psychology and in medicine. The Tuskegee experiment, for instance, right? An experiment where Black men were told that they were going to be treated for syphilis, but instead they were not. And then the experimenters observed them over a series of years as the men got sick, had debilitating illnesses, in some cases went insane as a result of having syphilis, and died. Part of the lack of ethics in psychology and medical science is the reason that overall as a population, African Americans tend not to trust hospitals and tend not to trust doctors. A recent study came out that said basically because of this this background of this failure in ethics, African Americans overall tend to prefer having an African American doctor. In other words, you don't really like the field, so you don't get yourself treated, right? You don't get tested for things like high blood pressure, high cholesterol, all that kind of stuff. But then if you go, you prefer an African American doctor. That's a result of our ethical failures in science when it comes to participants. And those failures last generationally. So when we fail others, when we have poor ethics, we hurt them and we hurt them for a long period of time. People who are coming into your laboratory to do a study, or you're going out to meet them to do a study, you are gaining data from them, you are taking something from them. When you don't have good ethics, you are taking more from them, and what you're taking from them will hurt them. So we have to have good ethics when it comes to the field and how we do experiments. So hopefully we'll briefly discuss that, right? But there's federal regulations as well as an APA code of ethics, right? So we have to have things in place to protect our participants. First, we have to have informed consent. Informed consent means that I tell you what's going to happen in the study so that you are aware, and then you sign a paper that says, I have informed you about what's going to happen and that you know what to expect. At the end of that experiment, we do what's called a debriefing. I tell you exactly what we went over. I tell you exactly what I was looking for. I tell you what the findings are. And I give you a way to contact me for the next 5 to 7 years in case you have questions about the study. And informed consent, I give you the ability to withdraw from taking part in the experiment at any time without consequence. I also make it a point to minimize discomfort. If I bring you into my lab to test sort of your physiological response to movies that depict horror and gore, I try to minimize your discomfort with what I'm hooking you up to, and then offer you a chance to leave the experiment anytime if you see something that you really don't like. I also have to have your data be confidential. I have to have your data locked up in a file cabinet or on a terabyte drive that itself is locked up, that no one has access to except for me as the experimenter and the other researchers who I'm working with. But we put the data back and we keep that data for 5 to 7 years, in some cases 10 years, depending on what the data is. We make the data in such a way that we cannot track your individual responses. We make the data in such a way that if you come into my study, right, let's say on a questionnaire, I'm asking you about your sexual orientation. I'm asking you about your sexual preference in terms of what gender pronouns you wish to be referred to by. Well, it might not be knowledge that's released yet. You might be very private about that information, but you're willing to tell me that information in the study. So when I give you a questionnaire, I do not say Calvin Sims identifies as she, right? I say number 10756 identifies as she. I make it to where I do not attach any personal identifiable information to the data that I collect from you. If the worst thing happens somehow and there's a data breach, you are still protected because I can't tie your information to you. Now, keeping it real, there's ways that I can go through my data to backtrack to figure out who answered what question. And sometimes you need to do that. Those cases come up sometimes when you're doing experiments, but they don't come up often. Sometimes they come up. But I don't implement that unless there's an actual real need for it. So to protect you as my participant in the study, I make it to where no one can ever track your answers to you. Sometimes deception is used in the study, and deception means in order to test something, I lie to you. It's very hard to get that kind of study passed. When you're proposing a study, you have to submit your study to something called an institutional review board. I served on the institutional review board at UNC Chapel Hill. I served on that for 2 years. And my job during that time was to review studies, send them off for a review. And in these review sessions, about 12 individuals get together for a month. They discuss the merits of your study, and they discuss why it should or should not pass, what modifications need to be made to it, and what type of research it is. If you're going to use deception in your study, you have to have a fantastic rationale for why you're doing it. They're very hard to get past because ethically, we don't want you, the psychologist, lying to your participant. We don't want the researcher to lie. But sometimes to test certain things, you have to be dishonest in doing that. So if you are using deception, then when you debrief, and this sentence that's written on the slide is a little misleading because the sentence says, if deception is necessary, debriefing must occur. Well, debriefing always occurs, whether or not you use deception. Debriefing is always happening. You always have to tell the participant what you were looking for at the end of the study. But if you are deceptive, you must especially spend time to talk to the participant about why you lied to them and why lying to them was necessary for the study that you were doing and for the concepts you were testing. Debriefing is this special time between experimenter and participant where we talk about what you just did in the experiment. Sometimes what you did in the experiment is, if I'm testing the concept of sadness, you might leave the experiment with lower affect. Let's say I'm testing sadness and let's say I'm testing sadness on how many cookies you eat, right? So I show you an hour of sad scenes from movies, and you leave the lab in a very sad space. Well, to debrief, I need to tell you why I did that. We have to have that conversation, and I might give you more cookies. And depending on the study, we might actually spend a few times watching some happy films, right? Let's say we're in a mood manipulation study. So debriefing always takes place. You always do informed consent. You always do debriefing. We do utilize, especially in biopsych, the study of animals in order to understand certain concepts, right? So we might want to study basic research on particular species. You might want to discover practical applications. You might want to clarify theoretical questions. And we might also want to improve human welfare. There are many animals whose brains are very similar to human beings, and there are many animals whose reactions to certain concepts resemble how human beings react. But it wouldn't be ethical to put a human being in a study because a human being could be seriously hurt or harmed, or otherwise placed at a very severe disadvantage. Now, the argument is made, and I especially understand this. The argument is made that studying animals has its own ethical implications and its own ethical disadvantages. But for now, you'll note that we study animals a lot because it's the easier, more ethical thing to do in terms of what would happen if we were studying human beings. And right now, and if you're someone who loves animals like I do, that is difficult. That is very difficult because we don't want to cause undue harm to life. Life is very precious. Life is very valuable, right? But in order to study certain concepts, animals provide a great benefit to us in order to do so. But that is definitely a conversation that is something we need to have and discuss in terms of the usefulness of animals and our understanding of biology. So, and this is something that we've spoken about a little bit before, right? You can manipulate numbers. You can manipulate numbers, and you can lie with statistics. Always, 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 always ask. Always ask. Who did the research? Who benefits from it? There's a terrible lie that people believe. People believe that red wine or a glass of red wine is good for you. It's good for your heart. It's good for your body. Red wine is healthy. Now, this came about due to a study some years ago that was done to look at individuals who drank wine, right, with heart issues and those who didn't. And it was found that those who did not have the heart issues were more likely to drink wine. So the assumption was drinking wine makes you less likely to have heart issues due to the tannins in the wine. And then additionally to that, some news anchor, some very famous news anchor spoke about the study on television. It was local news, and basically ended the news segment by saying, well, I'll drink to that. The industry went wild. Boom. Everyone's drinking red wine now. You see it in newspapers, you see it in magazines, you see it on ads on YouTube. Drink red wine. It's good for your heart. Drink red wine. Who did the study? The study was conducted by a group of individuals who worked for an alcohol company. If you actually look at red wine, what you find is that there is benefit to the tannins that are in the grapes that are used to make the wine. However, the benefit of the tannins is actually completely overshadowed by the effect of the alcohol in the wine. Alcohol itself is not good for you. It relaxes you. People think it relaxes them. Tastes good. It's fun. You socialize with your friends. Alcohol is not good for your heart. Actually, alcohol, especially if it's alcohol misuse over a long period of time, can destroy your heart because it enlarges it and actually harms your other organs, especially your liver. The tannins in the grapes themselves are good. The alcohol itself is not. Who did the study? Who benefits from the study? If an alcohol company does the study and you read that, you go out and buy 12 bottles of wine, you have just made them a lot of money. So companies do not mind investing a whole lot of money in studies and marketing the findings of those studies, which somehow happen to always be in that company's favor, because it will get you to spend your hard-earned money supporting that company. Who did the study? Who benefits from the study findings? Always look to see where the data is coming from, right? We saw this in the 2016 elections, right? Hillary Clinton projected to landslide Donald Trump. The polls say she's leading, it's going to completely wipe him out. That did not happen in 2016. Who did the studies? Who was doing the polling? Organizations that had a left-leaning or Democratic-leaning board organization. They did the polling, and in the polling, who did they ask? Mostly Democrats. Who were you voting for? And then what happens in 2016? For some reason, everybody is completely shocked. Donald Trump has won the presidency. So always look to see who conducted the study. That's the number one thing. You take nothing away from this conversation about statistics. Take away that Dr. Sims said, who did the study? Where does it come from? Who does it benefit? What were the base rates? What were the absolute numbers? How do they define terms? What is the point of the study? Why did they release it? Where did they release this? A study that's released in the Journal of Asian American Education is going to have a different audience than a journal that's released in People magazine, right? So because different journals have different audiences, why did you release that at a specific audience? So always look at studies with a critiquing eye. Now, there are some studies that are done very well. Most studies are done pretty well, I'd say. They come from very reputable laboratories that provide us real data. But question where that came from so that you don't get fooled into believing things that the masses believe that are not true. Like red wine is good for your heart. And today, if you try to tell somebody who drinks a lot of red wine that it's not, they will get upset with you. But you're the one with the knowledge now. So be careful where that comes from. And that, my friends, is the end of this week. So you've been bearing with me, which I really do appreciate, and I value you all. We had to get through chapter 2, because if you don't get to do chapter 2 in this way, you're not going to get anything else. Next week, we begin the fun stuff. Well, this is fun too, but we begin the biological stuff. I'm very excited for where the week takes us, all right? So enjoy today. Be safe out there. Do not forget to double mask up. Do not forget to socially distance. We're still in the middle of the pandemic. I know it seems like we've been in the pandemic forever. I know that there's pandemic fatigue, but we're still there. We're still fighting together. And I want our UNT family to remain safe. So still be safe. And if you have any questions at all, please let us know. We're more than happy to answer them for you. But I will talk to you again next week.